My name is Eric Johnson, and I'm a Senior Developer Advocate for Serverless at AWS. And I'm glad to see you here virtually at GOTO Chicago. Today we're going to be covering leveraging serverless in full stack development. Tell you a little bit about who I am. Let's get started here. All right, so who am I? Well, I'm EDJ Geek on Twitter. So if you're looking for answers for serverless or looking to find out, more about serverless, glad to help you there. I'm a husband and father of 5. That's not a typo. Yes, I have 5 kids. It's crazy. We're all quarantined in and going nuts here. In fact, you might hear them in the background while I'm recording this. I'm a Senior Developer Advocate for Serverless at AWS, which I already mentioned there. I'm a serverless tooling and automation nerd. I'm really a tooling and automation nerd in general. I like to do a lot of things there. I'm a solutions and software architect. I've been doing that for greater than 25 years. I'm a music lover, pizza lover, without pineapple, of course, and a pusher of serverless for everyone. You can see my shirt here, serverless for everyone. It is a big thing for me. And we're going to jump in and we're going to get started here on talking about serverless applications, or where serverless can plug in full stack development. So let's get started. First of all, let's talk about the application architecture journey. Now, hopefully this is a room full of developers or a virtual room full of developers. You've been developing and you probably started somewhere along the line here, be it in your own house, be it with a company, something like that. But most applications, most developers start out with a single computer, and on it you're going to have maybe a proxy, a firewall. You might run Nginx or Apache or some type of server, IIS or Apache, Tomcat, things like that. You'll have your code on here. It could be Node, .NET, Python, Ruby, any number of things. And you probably run your database on here too. So you run your SQL Server, MySQL, Postgres, Mongo, all kinds of different options. But we all kind of start in the same place where, we're running that service, in a server in our mom's closet, something like that. Okay, so when we think about this, then we think, what? We can break these applications into their own tiers, and we come up with this tiered architecture, okay? Where we might move our proxy and our firewall off, and we have our server, maybe our database in a separate place. We might even get crazy and split our client out as well. So where we have our proxy, we have our client, our backend, different things like that. And this is probably, you stay in these servers up in your office. You might have a computer room. You might have your own data center, right? So, but when we start building like this, as applications scale, we have to build in redundancy, right? So we think about, okay, we're building this. Now we, all of a sudden we're in production. We're getting a lot of clients. And so we can't afford downtime. Now, some sites can. I have a blog I run. My mom, maybe my brother read it. If it goes down, nobody's going to lose their mind. But a lot of us work for companies where if your site does go down, that's a lot of money lost. And so we have to build in redundancy, okay? So what does that look like? Well, we might have a proxy or firewall in front of it, and we might have 2 here. I'm just showing one, but we might have like an active, passive, active, passive, some kind of combination where we're setting that up. And then we got to introduce a client load balancer. So we're going to run our clients. We're going to load balance to several different servers. And then we need a load balancer on our back end as well. Okay, so our client to kind of talk to that. Maybe that's our API. It's a load balancer that points to an API. And then we have our back end. And of course, our back end may point to a database. And our database is going to be redundantly, synced over. There's all kinds of different patterns. But you get the general idea. To build in redundancy, we need more machines, okay? Now, this is great for us because we go, oh, man, I'm excited about this. We've got a lot of business. We've got a lot of traffic. So, we need this. But then we get more and we get more and we get more. And here's what that looks like when we look at the more redundant tiered architecture. Okay, so we get into saying, okay, 2 servers isn't going to cut it. I need 5, I need 15, I need 30 servers. And I've got to balance this out across multiple backend servers and client services and different things like that. And it becomes kind of crazy. And really, it's more redundant, but it's more infrastructure, more management, more cost. Okay? And I know you're thinking to yourself, hold on. What about containers? Well, okay, fair enough. So we have this, idea of the proxy firewall. And let's say, we're running our client or backend or database all in the same. Maybe we split it out a little bit. But the reality is, it's still on hardware. It's still hardware you have to manage. So we need to build the more redundant containers architecture. So what does that look like? Again, proxy, and this may not match exactly. This kind of encompasses a lot of different, things that can happen. But we have the proxy, we have, a load balancer kind of balancing that out. And then we have our client, our backend, and then we roll our database off into a separate service, maybe even some containers, but definitely rolled off into its own tier, okay? But the reality is, even with containers, you have more redundant, more infrastructure, more management, more cost. So, okay, we're going to move to the cloud. And that's a good idea. Hopefully you're not running your own architectures in your own offices, because, the reality with doing that is, when we need a new machine, we need a new server, we sketch it out, we plan it out, then we order it, then we provision it, then we patch it, then we build it, then we do all the things, and those are out of date, then we got to patch it again, and then we're finally ready to load stuff onto it, okay? So you say, you know what, we're going to move to the cloud. So let's look at what that looks like in the cloud. All right. So this isn't a containers. This is again a virtual machine or an instance setup. And with the cloud is great. We have the ability to build in some different architectures where we can have instances in multiple availability zones. We can have auto scaling. You have application load balancers that are managed services. We have managed services for our database. There's a lot of power in the cloud. I mean, I've been an AWS solutions architect for a long time, and I've helped a lot of companies understand what embracing the cloud looks like, okay? What about containers in the cloud? Same thing. So you have the ability to say, look, I'm going to have, even if I'm using the managed service like ECS, which is Amazon's Elastic Container Service, you could pull this out and pop EKS in, which is Amazon's Elastic Kubernetes Service, or even Fargate, where that can grow and can add some stuff. But the thing about that is, with these container services, there's still hardware or still infrastructure to manage. Okay. The truth is, moving to the cloud offers sophisticated automation and tooling to help manage scaling and redundancy, but there's still infrastructure to manage and to pay for. So that's why we're going to get to what I'm here to talk about today. You kind of get this idea. This is a story that a lot of, engineers go through, and how do we support architecture and how do we build this out? Well, let me tell you, and let me welcome you to serverless. Say hello to serverless. Howdy, serverless. Okay. Alrighty. So we jump in here. Let me just explain. Hopefully we may have some new folks. Now I am going to tell you straight up. Everything I'm going to be talking about today is going to be AWS-based serverless. And the reality of serverless is it's managed services. And I don't apologize for that. That's a good thing. And AWS has been doing it a long time, and we're one of the front runners in it. But some of the technologies I'm talking about, you can look at some of the other services like, with Azure or Google or something like that. But it really is kind of a vendor, and yes, you may hear the vendor lock-in. I don't know if I'd go that far, but they're vendor-specific kind of services that we work with. So you're going to see some AWS stuff. And here's how we approach serverless and what we believe about it. Now, the truth is, 100 people in the room, maybe there's 100 here. I like to pretend there's 1,000 or there's 2, so I'm not nervous. If you ask them to define serverless, the reality is a lot of times we'll say, well, serverless is, I don't know, 100 people in the room, I'll probably get 100 different definitions. Maybe 107, because people always change their minds, right? Oh, I like what they said, okay? But here's what serverless is based on how we're going to approach it. Kind of have the same definitions. There's 4 core tenets to what we look at when we say what is serverless. The first, now, I don't know if my hands or if my face will be up on the screen here, but I'm holding my hands up. There are some rules when I talk. I may be holding up one finger, but I mean whatever I say. So you have to bear with me here. These are the rules when Eric Johnson's talking, because sometimes the hands don't always match what the lips are saying. So there's more rules, and you can catch any one of my other videos to see those, but I encourage you to just have some fun. All right, so what is serverless? So the first thing is there's no infrastructure provisioning and no management, okay? So you don't have to spin up anything. If you do, then it's not serverless, right? So our goal is to have it where you have no infrastructure. The second thing is the infrastructure that you're not managing, but to support your system is auto scaling, right? So it has the ability to grow as you need it, but go away as you don't. Right? So the third thing is pay for value. And we really say that is pay for what you use and only for what you use. When we talk about how serverless is built, it is for exactly for what you use per invoke or per request or per storage, things like that. It's not per machine sitting out there 7 days a week, 24 hours for 30 to 31 days in a month, okay? If you're not using it, you're not paying for it. And the final thing is highly available and secure. Okay, so what we need, what we offer, we as a cloud provider, we have really mastered the idea of multi-regions and multi-availability zones, and our serverless infrastructure follows that same kind of structure, where we're going to build in highly available architecture to support your system. We also build in security, and while security may be the last thing I'm talking about here, it's the first thing that we do. When a Lambda comes up or one of our serverless architectures, they come with security. We use our identity and access management heavily to get very granular security in your serverless applications. Excuse me. All right, so let's kind of break down what is serverless and kind of get an understanding. So this is pretty complicated, so stay with me. So I'm gonna define kind of the serverless idea. Okay, here it is. Something happens. We recognize something happens, and we do something. There you go. That's serverless. Something happens, we recognize something happened, and we do something. So let's get a little more technical than that, okay? So you're like, well, boy, I need more. All right, so let's start with the something happens. So the idea is serverless is event-driven. Okay, everything's event-driven. You're not necessarily polling, you're not necessarily looking, you're reacting when something happens. So you have an event source, and this could be a change in data state. It could be a request to an endpoint. It could be a changes in resource state. It could be a click of a button for like IoT. It could be any number of things. If you have an Alexa in your house, you're using serverless. When you talk to Alexa and that triggers that voice, then it sends information to make that change. Like you say, hey, Alexa, turn the lights on. It uses serverless to do that. So what happens when that event goes off? Well, generally, and there's some other patterns that we can get into maybe at another time, but generally it triggers a Lambda. Okay, a Lambda function is the compute part of serverless. And that allows us to have, and you can run all kinds of different languages like Node, Python, Java, you can see them here. But that last one, you're like, well, that's not really a language. Nope, the last one is our runtime API, okay? And that allows you to do custom languages. So you can say, hey, I want Rust, or I want R, or I want great thing COBOL, or something like that. And you can make a runtime of that. And we have lots of examples out there on the net that our customers are building. Okay, so Lambda gets fired off, it runs your code, and then it does something. And it could push data into a database. It can turn a light on across the world. It can, start a car. It can do all kinds of different things. It's however you want to do it and what services that are available to you. Some of the most common things we see with this are web apps, backends, data processing, chatbots, Alexa, as I mentioned earlier, IT automation. There's just all kinds of examples where you can use serverless in the world. But we're going to climb into, like I said, we're going to be talking about full stack development and kind of web apps and backends. We're going to spend most of the rest of the time here. So let's get to this, all right? Serverless and full stack development, okay? So let's go back to our architecture that we had, okay? And we're going to talk about how do we move to serverless. We've got an architecture built. So how do we move to serverless? And in this, I'm going to assume that your client is separated from your backend. So you've got a client and a server separation. But if you don't worry, I'll cover that too. Okay? So moving to the serverless client. So what we're able to do here is the first thing is we're going to break out our client, and instead of running it on a server or multiple servers and running the load balancing and all that kind of stuff, we're going to move it into Amazon Simple Storage Service, which is also known as Amazon S3. Okay, and you can see here that it has hosting for HTTP and HTTPS. You can put your domain name right on top of that. You may not have known that you can host a website right in the bucket. And what you get is you get that large, you get that huge scalability that comes with S3. All right, and that 99.999 whatever 11 nines data durability. Okay, so there's a lot of strength there. But one of the cool things is we now have a new service that's called Amplify Console. Okay, and it actually has S3 behind it, and it also uses Lambda at Edge, which is an edge-based compute to do a lot of stuff for you. That we can do rewrites, we can do global availability through CDN, we can do basic password protection, all kinds of things like that, and it automatically gives you a CI/CD, which is a continuous integration, continuous delivery. So if we think about that, we can pop that right out, and we can take our client and drop it right into Amplify Console. Alrighty, so the next thing we're going to do is we've gotten rid of the proxy and firewall, and that now or not gotten rid of it, but it now points directly at our backend. Okay, so now we want to move our backend, right? So we're going to get rid of our firewall. So instead of using use some servers to handle our proxying and our API gateway and things like that, we're going to use Amazon API Gateway to be our endpoint. It's our API endpoint that we can do. Okay, so now I've gotten rid of all my load balancers, I've gotten rid of firewalls, I've gotten rid of my proxy servers, things like that. Now all I've got is just API Gateway in front of my servers. Okay, so now let's get rid of our backend. Okay, so I can take all those services running on all those servers and put them in a Lambda or a conglomerate or a group of Lambdas. Now, in a microservice world, we don't encourage you to say, hey, take thousands of lines of code and shove them into one Lambda, but you can break them down. And the nice thing about this is going to scale as needed. Okay, and we'll talk about that in a minute. Finally, for database, I'm not going to run my database in servers anymore. I'm going to move to a managed service, and we have all kinds of options for this. Aurora, we have Amazon Document DB, which is MongoDB compatibility, DynamoDB. There's all kinds of different databases that we can use, and we won't cover all that in this one. But know that whether I'm running SQL, whether I'm running document, whether I'm running NoSQL, that kind of stuff, we have, or time-based. We have all kinds of options for database in a managed service where you don't have to control the infrastructure underneath to support it. All right. So the main ones that we use in web stacks are generally Aurora, which has Postgres and MySQL on a very scalable platform. DocumentDB, DynamoDB, which is my personal, that's the one I use all the time. Love it, it's fast, it's very robust. And Amazon RDS, great for if you're running relational database services. Okay. So when I move to this, again, we separate these out. Aurora, there's different things you can do on this. You can have with Aurora serverless. It is serverless. And the ability that as you need more, it adds more. You do not maintain the fleet for this. All you maintain is the data in it. Amazon RDS, again, engine native replication, Microsoft SQL, MySQL, PostgreSQL, MariaDB, Oracle, so on. Amazon DynamoDB, if you're familiar with the little thing we like to call Black Friday, Amazon DynamoDB is a big one in this on how to handle the massive load that we have there. And finally, Amazon DocumentDB, if you need that MongoDB compatibility. All right, so let's put it all together and see what it looks like in an architecture. All right, so a general hosting, a basic website, we're going to have, as I mentioned, API Gateway in the front. We're going to have a Lambda function that's doing Lambda or multiple Lambda functions that handle our code and handle our compute. And the nice thing is HTML can be rendered by the Lambda function return. Now, remember I said, hey, if your client isn't separate from your backend, that's okay. You can render HTML from a Lambda. I don't suggest it just because it has nothing to do with serverless. Just a good pattern is to separate your client out from your backend. But there's a lot of things that are still being done with rendering Razor or Pug or some of the templating engines to render from the backend. Whichever you need, you can do a lot of that from Lambda as well. Okay. Now, if you're using RDS, now you could use one or the other or a mixture of both. If you need relational versus NoSQL, something like that. One of the cool services we have is this thing called an Amazon RDS proxy. And so, because Lambdas are very ephemeral, they come up, they go away. Managing database RDS connections can be a little complex. So instead, all you have to do is point your driver, Postgres driver, whatever, at an Amazon RDS proxy endpoint that will give you, and that will maintain the connections for you. So very powerful, works with the relational database, just came out here in the last 6 months or so. Okay, so here's the cool thing. Because these are all serverless, every one of these are going to scale automatically as needed to handle client requests. API Gateway is going to scale. Lambda function is going to scale, DynamoDB is going to scale, so on and so forth. So you have massive scalability without having to maintain all the all the infrastructure under it to do that. Your client application is going to be hosted on AWS Amplify Console, like I was talking about before, and that's going to again be hosted in a serverless, scalable way. And then for authentication, you can actually use Amazon Cognito, which offers user management and authentication. Okay, so remember what I said earlier, each Lambda function can have a single responsibility, so we can use more than one Lambda to build our architectures. So we might say, look, for users /user ID, go to this Lambda. For reports, go to this Lambda. For orders, go to this Lambda, so on and so forth. So you have a lot of ability to break those down. We have lots of different, and I'll show some resources in a little bit. We have a lot of different videos and content on how to build architectures very granularly and with microservices. All right. So finally, you can also do, we talked about putting stuff into DynamoDB or using database. Also, with some of these databases, you can do stuff after the fact. So asynchronous post-processing via streams and event buses. So it allows you to have very loosely decoupled back-end architectures. And that's how we build architectures nowadays. Microservices that are loosely coupled or decoupled entirely so that they're not brittle and so that they degrade gracefully. All right. So how do I get started? Well, I got to say this, start with the framework. Okay. And what that means is don't try to hand roll Lambdas. You can, if you want to, you're welcome to, build all your IAM, all that kind of stuff on your own. But I encourage you to start with the framework. And there's some great ones out there. My favorite is AWS SAM, which is the serverless application model. And this comes in two parts, and this always freaks people out. I'm going to split the squirrel in half. This is Sam the squirrel. He is our mascot. And these are the two parts. We have the SAM templates, which is an infrastructure as code, and it is a subset of CloudFormation. If you're not familiar with that, it allows you to design a template, and that will actually bring up the infrastructure as needed. And then there's the SAM CLI, which runs locally on your machine, which provides tooling for local development, debugging, build, packaging, and so forth. And you can see the link there to check more out about that. I also have a series that I do on Thursdays called Sessions with Sam, where I talk through a lot of this on Twitch. It's a live stream, and I'll have a link to it shortly. There's also things like AWS Amplify, which is designed for front-end developers, although you can get into the back as well. You can get into, you can deal with different types of APIs if you want to do GraphQL API through AppSync, or you can use API Gateway. Very, very powerful. It works hand in hand with Angular, Vue, or direct JavaScript. Incredibly powerful, and there's a link there. Some other frameworks, third party, serverless.com is a great partner of ours, and as well as a lot of these great other ways to build out serverless architecture. And so I encourage you again. I would just say again, start with a framework. All right. So a couple of resources before we wrap up here. Final resources. The first I'm going to give you is this is our AWS Serverless. And this will take you to our AWS Serverless page. Slip.link /AWS Serverless. There's also the QR code. It's just a good place to kind of read about what is serverless, what does it mean, why use serverless, kind of go more in depth than what I've talked about here today. The next one I'm going to give you is our AWS Serverless YouTube channel. This is new. We just started this. You can find it at slip.link /serverless. There's our QR code as well. And this shows how to build a lot of things with serverless, including there's that, you see that slip.link, and you're like, what is that? Well, that's a URL shortener that I built entirely serverless. And I talk about how I build it in a way that's massively fast, massively scalable, and pretty darn cheap too. So you can take a look at that. That's in, I do it under a thing called Happy Little APIs. You can see it in the picture there. And with that, I'm going to give you a thanks. Again, my name is Eric Johnson. I heavily encourage you to follow me on Twitter at EDJGeek. And I hope you have a great day. Thank you.